So to get started this morning, we have a presentation from Steve Ives. Steve is going to guide you through xfServerPlus, what it is today, and then what the next evolution may be for your application with Synergy.net. Please welcome Steve Ives.
Thank you, Nigel. Okay, so as Nigel says, in this session what we're going to do is talk about a little bit about xfServerPlus and some things that you can do in some scenarios. And not saying that this makes sense in all scenarios, it certainly does not. But there are some things that you can do with Synergy.net in some cases that may, depending on your scenario, make sense for you. And that is to consider the use of something called Synergy.net Interop. There are some people in the room who've done this and had some great results with it as well. So this is certainly not to be confused with the .NET API, .NET Assembly API that we also kind of tended to refer to as Interop. That was traditional Synergy interoperating with .NET, using the stuff that Richard showed you the other day, putting WPF forms in your toolkit applications or non-toolkit applications, that kind of thing. That's a whole different Interop. The Synergy.net Interop project template is what I'm talking about here, and I'll explain what it is and how it works. And what this project type gives you is potentially, in some environments, a way of factoring out xfServerPlus and xfNetLink.net from your existing applications. I already mentioned it's not applicable in all cases, and hopefully I'll help you understand when you might want to consider doing that. I do want to stress that xfServerPlus is still a fully supported product. I am not trying to encourage you just to move off xfServerPlus for the sake of it. It still has many scenarios where distributed processing is still absolutely the right way to go, and depending on how the application is configured and deployed and what runs where and where the data is, there's no right answer in any given scenario. What you need to do is look at, what are we trying to achieve? Is it a web app? Is it a desktop app? Is it a mobile app? Where's the data? Are there any other systems involved? There's a lot of moving parts when it comes to this decision. So this is absolutely not about getting rid of xfServerPlus for the sake of it, but like I say, in some scenarios it can make a lot of sense to do that. And those scenarios primarily are where everything's on one system, okay? Typically Windows. So if you've got a lot of us use xfServerPlus just as a bridge to get from, that's probably a bad choice of word these days as well, but just for a mechanism to get from a C# web application into traditional Synergy code so that we can get to our underlying data, and the whole thing's on Windows. And obviously with xfNetLink and xfServerPlus, we've got TCP/IP layers and networking going on, even though everything's physically on the same box. So the primary scenario where this thing comes into play is where we're talking about Windows and where you've got everything on the same system. And then the Interop stuff can make and that's a lot of cases. A lot of people do exactly that. And then it can make a lot of sense. There are some other scenarios as well that we'll touch on a little bit later. Before we do, let's just set the stage, because not all of you are probably familiar with xfServerPlus, so I'm just going to briefly talk about what it does, because it will help us understand some of the pieces that are involved when we come on to use the Interop project later on. So xfServerPlus, if you're not familiar with it, allows basically traditional Synergy applications, good old subroutines and functions, to expose callable functionality, kind of like a remote procedure calls environment. So it gives you a way of calling Synergy functions from other places, typically from, not always, but typically from non-Synergy applications. And the primary examples, we've pretty much always had 3 clients, one of which isn't supported any longer, but there was a COM client, if you remember, in the old, you would use that kind of in the old C++ environment perhaps, or in, if you were doing VB6 type development back in those days, the COM client would be used. We have a .NET client and we have a Java client. So those are the types of applications, and there's some client functionality built into Synergy itself as well, so that you can do distributed processing within the context of a Synergy application. So those are the places it tended to be used from. But typically it was a Synergy server and data and non-Synergy applications of some kind, and there's a TCP/IP communication layer that's used between the client and the server to allow you to get over networks and from system to system and so on. So typically it's a bridge from traditional Synergy, or between traditional Synergy and OO environments in other languages. This is what the kind of topography looks like when you're using xfServerPlus, or partially at least. So the first box on the left-hand side is representing the client application, and it's got its UI logic, and it has the yellow box there on the left-hand side is the xfNetLink client that we provide that gives you a bridge of way of then bridging over the network, the red line there representing the network, to xfServerPlus on the server system, executing business logic, accessing Synergy data. If it was a true 3-tier application and the data was remote somewhere else, then that could have involved another hop over a TCP/IP network to xfServer on some other system perhaps to get to remote ISAM data, or using our SQL connection API to use the Vortex channel to get over to a database server running Oracle SQL or a MySQL, SQL Server, some kind of relational database. So that's what the building blocks look like in an xfServerPlus world. And obviously those technologies, there's really no limit on what you can do with these technologies. Between COM.NET and Java and Synergy as well, you can get into one of those environments from pretty much anywhere. You know, there are ways of getting into Java from other environments apart from Java and consuming Java components and so on. So these technologies wound up being used in desktop apps very often. They wound up being used in a lot of web applications. An awful lot of web services were built with these technologies as well. So exposing a true web service and then using one of the xfNetLink clients, be it Java or .NET, to get back into Synergy, and then having a mobile phone application communicating with a web service or something like that. So there's really a very wide range of applications that xfServerPlus typically has been used to implement. xfServerPlus exposes what we referred to as Synergy methods. There's nothing special about a Synergy method, it's just a subroutine or a function that exposes certain parameters, has certain return types, and does some job of work, just like any other subroutine that we call. But these methods were written to implement the discrete pieces of functionality that we needed to service the requirements of the client application. And very often they were just accessing a piece of data, you know, posting some new information in, validating something, looking something up, you know, reading a record, returning a collection of data, whatever it happened to be. So they're exposing the business logic, and behind that the data that the application uses. It is traditional Synergy, so it's subroutines and functions. This is totally cross-platform. The server is supported on all of the platforms that we support using traditional Synergy. And one of the biggest advantages of xfServerPlus was it was very easy to get up and running with, because it's just subroutines and functions. And we all know how to do that. That's what we spend our lives doing when we're doing Synergy coding. Up until OO days, of course. And xfServerPlus exposed subroutines and functions and also data structures. So it also, as well as giving us a bridge for getting from another language into Synergy, it also gave us a way of bridging those Synergy data types, our records and fields and alphas and decimals and integers and implied decimals and all of that kind of stuff. And it gave us a way of wrapping that up in a different format that made sense in whatever the client environment was. So in the .NET client, we expose a record as a class, and that class has properties that represent the fields, and we transpose the alphas into strings and the decimals into ints and things like that. So we expose a native API in that .NET world. And that's important to bear in mind, because the existing client applications obviously have been written to that exact API. Those subroutines, those methods, those parameters, those data types, those structures that have been turned into classes and properties. Your client developers have written a lot of code over the years that expects that exact API to be there. Okay, and that's how they interact with it. Just bear that in mind. xfServerPlus also used this thing called the Synergy method catalog that was maintained by a utility called the method definition utility, and that was basically just a collection of metadata that defined to the tools in the environment what is available. So you build your subroutines, you put them in an ELB or a shared image if your server is VMS, and you then had to define those methods in this method catalog in order to declare that they are present to xfServerPlus. It obviously has no knowledge of whatever you write, so you use the catalog to tell xfServerPlus there is a method out there in this ELB and it has this name and these parameters and this is how you call it. And the xfServerPlus can then, when it gets a request to execute that method, it can look that method up in the catalog and say, okay, it's a subroutine, it has 4 parameters, and it can take the data it received, wrap them up in the appropriate way, and call into that routine. And also understand what's going to come back from that routine, the data that it needs to send back to the client. Originally, we used to have to manually create that method catalog, and in not recently anymore actually, it was introduced in 9.3, so several years ago now, we introduced a mechanism where you could add certain attributes into the source code to declare all of that extra information that the catalog needed, in conjunction with using extra features in the language, like the ability to declare parameters as required and optional and in-out and all of those good things. And you could actually then use a utility called DBL2XML, and it would generate the information by reading the source code. And you could load up the method catalog automatically as part of your build. And that's an important component of the stuff I'm going to come on to as well, the presence of those attributes. There's an example of, if you don't know what that looks like, there's an example of how attributes work in traditional Synergy, and in Synergy.NET actually, the syntax is the same. So an attribute is something that decorates a piece of source code. For example, up here you can see we have this xf method attribute going on there, and that is basically saying this subroutine is a method that's going to be declared in the method catalog. We're declaring here you can see the name of the ELB that the method is stored in, and so on. We've also got some other attributes at the parameter level that are just providing additional information. You know, this parameter says it's a memory handle, but we're saying, actually, let's call it grfa, and it is a binary handle. So we're providing additional information over and above what the syntax of the language is able to specify. That's what those attributes are all about. And once you've attributed a piece of code, once you've added those attributes to the code, you can then use the DBL2XML utility and then use the MDU-U option, and hey presto, your catalog gets created and loaded up. So you can obviously add those tools to your build script and no more need to maintain the catalog anymore. xfNetLink clients, I already briefly mentioned these, so I'll fly through this, but primarily there's 4 of them, but really the 2 main clients that have been used historically are xfNetLink.NET and xfNetLink Java. And both of those tools take a very similar approach in that they expose classes full of methods that represent the callable functionality, and they expose classes full of properties that represent the data, and in such a way that it looks very natural in the Java or .NET worlds. COM is still available. The latest version we supported with COM was 9.5.3, but it is still out there, and you can still get it if you really need to get in from one of those old environments. And the xfNetLink Synergy client is built into the language as well. So that's kind of a little primer about what xfServerPlus was about. Briefly, the licensing model as well. If you're not familiar with it, xfServerPlus does not use normal runtime licenses. It has a separate licenses, and these are basically server-side concurrent connection or concurrent user-based licenses, where you have a number of license units, and that's the number of concurrent sessions or connections that your server can deal with at any point in time. And there is not and never was any client-side licensing. So your server has the ability to service a number of users or connections at the same time, and you can freely use any combination of clients without any licensing on that side. Okay, so strengths and weaknesses. xfServerPlus is a really easy way of going about building a distributed application where you have a fairly thin client that just really has pretty lightweight UI-based code in it, and all of the heavy lifting and all of the data work is done on the server. And obviously building distributed applications has been, you know, a desirable model for quite a long time now, a great way of building software and breaking up the application into its component pieces like David and Don talked to yesterday. Another advantage was it's a way of driving this from traditional Synergy code, which we've all got. Yes, we've got .NET tools available to us these days, but our primary code base is pretty much our traditional Synergy in most cases. It also gives us a way of being platform independent on the server, so we could choose whether we wanted to run or host our server side and our data on Linux or OpenVMS or Windows and freely move around between those platforms. It has some built-in logging and does have some debugging capabilities, but you'll notice I've put debugging on the opportunities for improvement side. And it does work with older versions. xfServerPlus goes all the way back to Synergy 6.3. So if you do have customers with older environments out there, you can still do this kind of stuff. And it's also very flexible. You can apply it in just about any scenario you can come up with. xfServerPlus could be a solution to the problem. But there are some challenges with xfServerPlus. There are lots of different moving parts. There's the clients and the server and the networks and all the tools you have to do to generate the client code and build it all and deploy it all. And installing client assemblies or client components on client systems. Multiple IDEs, typically you'd be dealing with Workbench or some other environment on a Linux or a VMS system, and then dealing with Visual Studio or some IDE for the Java client and that kind of stuff. You've got to deal with the method catalog and the method definition utility. It is difficult to debug. It's possible to debug. There are, now that we have, since we've had the remote debugger, there are ways of debugging server-side code, but it's not nice. It's certainly not a pleasant experience. The fact that you have to have custom client components to get into this world, and TCP/IP use, even though your client and your server might be on the same system. So there's some inefficiencies built in there that we now have ways of improving on. And that's really where Interop comes into play. So Synergy.NET Interop basically exposes a .NET OO API, just like xfNetLink does. If you think about it, what xfNetLink.NET does is it reads information, or it takes information that came from the method catalog, and you run a tool called GenCS. And what it does is it creates C# code that is a .NET representation of those objects and methods and properties, and that gets then built into an assembly that you reference in your application, and you make calls onto the xfNetLink client, and it routes things over the network and parcels up the data and makes the call on the server side and takes the data back and so on. So Synergy.NET Interop does a very similar thing. It code generates a .NET object-oriented API based on what's defined, well, I'm going to say in the method catalog. It doesn't actually use the method catalog. It uses those attributes that we talked about earlier in the code directly. But conceptually, you can think of it doing a very similar job to GenCS. So it generates a class with methods for all of the subroutines that you've defined, and it generates classes with properties for all of your data types. And the point of this is that it's generating Synergy.NET code instead of C# code. Well, okay, that doesn't really matter. Well, actually it does. But the biggest point of this is that the Interop project code generates the exact same API that GenCS generated. Okay? So the idea is that you can use the Interop project to generate a .NET version of what you had before from GenCS, and you can then just drop all the xfNetLink.NET stuff from your application, literally remove the references, and add a reference to the Synergy.NET Interop project instead. And in theory, and very often in practice, sometimes there's a tiny bit of tweaking needed, but in theory, your client application just continues running with no code changes required, because the API is the same. What's happening under the hood is very different. Okay, what's happening under the hood is there's no TCP/IP anymore. There's no xfNetLink anymore. There's no xfServerPlus anymore. Okay, it's just calling your Synergy code directly. Okay, but as far as the client application is concerned, it's an identical environment, and things just carry on running. Okay, and just to stress, this really is not intended for use with new development. There are other ways you would go about doing this. This is really for use if you've got an existing xfServerPlus environment and you want to get into native or native 100% native .NET and get rid of the xfServerPlus network layer. That's what this is for. Okay, you would do things in a different way if you were starting from scratch with a new application. So this is what the building blocks look like with Synergy.NET Interop. The application is the yellow box to the left-hand side with its UI code, and the Interop assembly exists in that client environment. Okay, so it's directly referenced by the application, just like the xfNetLink assembly used to be referenced. It exposes in the bright yellow smaller box there, this public API that was generated based on the attributes and the code and so on, but it excalls directly into your Synergy methods now. In process. So it's no longer making a call over the wire to xfServerPlus on some other system and running the code. It's running the code in process in the client application. So that can be both good and bad. The great thing is we've now, if everything was on Windows anyway, we're not using TCP/IP anymore. So we've probably gained a whole bunch of performance by doing that. But also it's no longer a distributed application either. It's now a monolithic client application running on the server. Okay, which may or may not be a problem. Very often, if we've written desktop, for a web application, that might be just fine. okay, if it's a web server. Even with desktop applications, most of us, very few of us, deploy desktop applications on individual, 300 individual PCs around an organization. Very often, by far the most common use case is we use Windows terminal servers and either remote desktop or remote app technologies to allow the user to execute those applications all on the central server. So again, it doesn't really matter whether it's a distributed application or a monolithic application at that point. But it's not right for all scenarios, of course. And I've already spoken to this really. This is a view of Object Browser, and again, the point is that if you look at the API that GenCS generates with xfNetLink.net, and then compare it to the API that Interop has created, they're not identical. There are some things that are not there, and some things that are slightly different. Some of the debug start and debug end methods that used to be there aren't there because they're not relevant anymore. So it's not 100% identical. But in terms of your methods and data structures, it is. And it's probably very difficult to see, but if you look up here, we even have connect methods and disconnect methods, just so that your code keeps running, okay? They don't do anything anymore. There is no connect and disconnect, but those methods are still there. So there might be a little bit of work you've got to do in your code. Your code there were mechanisms, of course, to auto-connect and disconnect. But if your code is calling connect and disconnect, you might need to look around that code and figure out, well, can we just delete that piece of code or comment it out, or do you need to do something differently where you're doing something else? One area that you typically have to look at is configuring the environment, because what you have just lost is all of the environment variable settings that were behind the xfServerPlus. How does it locate its data, where DAT : is no longer defined. So you will typically have to provide those environmental settings in the client application environment now, not back on the server. So that's typically the piece of work that you do have to do, just to make sure that your code has the environment that it expects to run in. So this is basically the comparisons of the two. Let's just bring them both all up at the same time. So these are kind of before and after, and obviously we've looked at this box before, but on the left-hand side we've got xfServerPlus with its xfNetLink to xfServerPlus connection over the wire, via the catalog, running methods in an ELB and accessing data. And then really with Interop there are two kind of scenarios. The scenario on the far right there is the one we just talked about. Now we've just moved everything onto the server and we're running everything 100% in process. Of course that might not be always appropriate. So it might be that the data is still on some other system. So in those scenarios now, okay, we've just got rid of xfServerPlus, but now we might need xfServer to get to the data. Okay, so again, this may or may not be applicable for you. So there's a lot of different things to consider when thinking about should we go to this kind of environment. But in certain cases, that's great. Certainly if you're going to introduce xfServer instead of xfServerPlus, some things change then, because it becomes fairly important to that point that the select class is a fairly important thing at that point. Because what you don't want to do is introduce a whole bunch of inefficiency in the way that you're reading data, particularly where you're filtering large amounts of data and reading a bunch of stuff and throwing some of it away in those typical read-s loops. That would at this point become very inefficient if xfServer was in the mix. So at that point, the solution to those kind of problems is introducing the select class so that you're again moving that filtering back onto the server side where the data is. So I'm not suggesting that moving to the model on the right or the model in the middle there is always the right thing to do. It does depend on your scenario, where your application is, where your data is, and what your goals are. But those are the typical choices that you have when you're in the Interop environment. Common hurdles. What makes this a challenge? Well, one of the common hurdles is that your code will be running in a .NET environment now, of course, and therefore it will be running in a strongly prototyped environment. If you don't know what that means, and if you're joining us tomorrow, you're about to find out what that means, okay? And we'll help you through that process. But you do need to recognize that 100% of your code, traditional Synergy is gone now in this environment. You are now a .NET application, and therefore your code has to run in a .NET environment. And the hurdle there is you have to be strong prototyped. So there will be typically, and remember, it's not necessarily just, a lot of xfServerPlus scenarios, pretty much has been, new code has been written to do certain jobs. But in other scenarios, you frequently call back into those old ELBs with the old code that's been there a long time, and that's where you're going to get into prototyping issues. Not with your nice shiny new xfServerPlus code, typically that won't be an issue at all. But where you're calling back into your older code, there might be some work to do to get that code up and running as .NET code, not traditional Synergy code. And some of the areas that you tend to get into are, some of the things that traditional Synergy allowed us to get away with, having duplicate shared data entities. So two commons with the same name that really aren't the same thing. All of a sudden in the .NET world, that's going to start causing problems and require some work to address. Same with global data sections. Circular references between ELBs. Another typical one. Jeff spoke to that somewhat yesterday, and again, we'll be dealing with these issues tomorrow when we look at putting traditional Synergy in Visual Studio as well. These are all things that are typically fairly easy to address, but that first time that you drop your your traditional Synergy code into Visual Studio, it's fairly rare that it builds first time. There's usually some amount of work to do, but generally speaking, it's doable. Other things you might need to look at, anything that's process-wide, commons, globals, channels, environment variables, because now, depending on the scenario, that code, previously with xfServerPlus, all of that stuff executed in a separate process on the server side, protected from all the other connections in all of the other processes. And now, if it's a web server environment, for example, now it's all in one process in multiple threads. So all of a sudden channels can start bumping up against each other and stuff like that. So there might be some work you've got to do with app domains to segregate code and stuff like that. So again, there's a lot of moving parts. There's no one size fits all, but generally speaking, it's very doable. So solutions, strong prototyping. Strong prototyping is basically additional compile time validation that's going on. So when you bump up against issues with strong prototyping, what the compiler is telling you is, you've got a bit of an issue with your code here, actually. This don't make sense. Generally, if you get an error because of strong prototyping, it's a bug in your code, really. Some of it's kind of, well, is it really a bug? Synergy, traditional Synergy always let us do that. But something's not right, basically. So it's a matter of calling routines correctly as they were intended to be called, passing the appropriate parameters to those routines. If you remember when you went to version 9 for the first time, you bumped up against a whole bunch of, wait a minute, this is a decimal and you're passing an alpha to it and stuff like that. Which is, okay, something we could always get away with, but it really wasn't a great thing to be doing. It's the same thing over again. It's just that when you went to version 9, you got that calling our code. Now you're going to get it calling your own code. Okay, but it's really the same kind of things over again, just a second pass. So strong prototyping, and again, most of you are going to be with us tomorrow for the post-conference workshop, and we're going to be dealing with these things in a lot more detail, so a lot of this stuff will make a lot more sense. Duplicate structures is another common issue that you can start running into. So structures in different source files that have the same name but do different things, have different members. In Synergy.NET, everything's in a single compilation unit now, and they're going to bump up against each other. So typically renaming things, refactoring things, picking which, if they're all similar and you could use one, then get rid of the others and use one, or you might need to start renaming some things potentially. Duplicate shared data entity. So again, the concept of multiple, this routine, this set of routines has this common called Fred, and this set of routines has a common called Fred, and they were all compiled individually in the past, so they never really came across each other. Now they're all in the same compilation unit again. So again, generally figuring out, well, are they, they may have the same name and this one's just got an extra one field in it, so maybe we can use this one in all cases, or again, do we need to start refactoring the use of one of them and renaming one of them to something else? Circular references, again, is unfortunately something that was possible in traditional Synergy to have, a subroutine in this ELB that X called this one and one up here that X called this one. And it's that chicken and egg kind of scenario. In .NET, you can't do that because it's got to be able to completely build this one and resolve everything, and you can't do it because it calls that, and that hasn't been built yet, but that can't be built because it calls this one. In traditional Synergy, we've got some really neat ways of dealing with that in Visual Studio, again, that you'll learn about tomorrow. But it's usually not that big a deal. The two common approaches with circular references are, take the circular reference thing and just put it at a lower level and move it into a different ELB is often the easiest solution. Or just take out one of the X calls and X sub R. So you don't have an X call for your backward reference, you just X sub R it, and now it's a runtime thing again. And it's probably not the greatest solution, but it is a workaround for the problem. The solution to process-wide entities in a multi-threaded environment. So if it's a web application, for example, and all of a sudden your code has gone from running in separate processes per connection to now it's threads within the web server, things like globals and commons and channels and socket connections and environment variables and various other things. Now you used to have your own set of those things, and now everybody's sharing one set within the process, which is the web server, or the app domain that is running the code inside the web server. Generally, this won't be an issue if your xfServerPlus environment has always been designed to be stateless, and many of them were. So this is sometimes just a non-issue, but if it does become an issue, then the solution again is something called app domains, and an app domain is a way of segregating code, putting it in a protected little area within a process. And we've got multiple, I'm not going to go into a lot of detail about that, but we do have multiple examples that are in the code exchange that show you how to do it in various scenarios. So again, there's a solution. That one can be a little bit more challenging. So that was an example of before and after kind of thing. This slide showing, multiple threads all going at the same set of commons, basically, and globals and channels. And the solution here is to separate these threads into their own app domains. Now they have their own common space and their own channels and their own global data per thread. So Synergy.NET Interop Strengths gives you, a way of migrating the backend to .NET without, well, it's not really a backend anymore, is it? It's not server-side code anymore. It's now just part of the application. But a way of migrating to native 100% .NET code without any significant changes, or possibly even any changes to the client environment. Simplified installations and configurations, and the biggest one probably is, very, very significantly better debugging and development experiences. But remember, again, the back-end code now is going to run as .NET code, not traditional Synergy code. It must, we're talking Windows here. This is obviously a .NET thing. The code no longer runs server-side, and multi-threaded might be something that we have to give some careful thought to. Okay, when to consider Synergy.NET Interop? It could be used pretty much in any application that uses xfNetLink.NET today. You could choose to move the code to that scenario and get rid of xfNetLink and xfServerPlus. The best scenario, like I've already mentioned, is when the client code executes on the same Windows server that hosts the data. Okay, and you were just using xfServerPlus as a way of getting into Synergy from that non-Synergy language. So very common scenarios where this makes a lot of sense is web applications, web services, desktop apps that you always deploy on terminal servers, that kind of thing. This can make a lot of sense in those worlds. But do beware of just swapping out xfServerPlus. You can get some performance benefits by not having the TCP/IP connection to xfServerPlus there anymore. But if that then means that you have to implement xfServer, now you've got network overhead there, and potentially much worse unless you're using select class to efficiently filter data on the server side again. Okay. Another, on the right-hand side here, integrated debugging can be just a huge win in its own right. And actually, the customer that uses Interop the most, who are in the room actually right now, and the reason they did it initially was just to get the development experience better. They basically build, I believe I'm correct in saying, they build with Interop during development, and so that they can do full-blown Visual Studio debugging, stepping from client to server, client to logical server code and through into traditional Synergy, and debugging all the way through. But they then still build ELBs and deploy with xfServerPlus. So they use Interop just as a development tool to get the Visual Studio debugging experience, basically. And obviously, a side benefit was, they had to get their code prototypable, which tightened up the whole environment, and probably fixed some bugs along the way, I'm guessing too. Typical steps to Interop: basically add and configure an Interop project into your existing Visual Studio. Well, often, it doesn't have to be the same solution, but add an Interop project into your Visual Studio solution. You then literally add the existing Synergy methods into that Interop project. And basically when you then build that project, we have tooling within Visual Studio that analyzes any traditional Synergy methods that it encounters in that project, analyzes the attributes that are present in the code, and basically does a similar job of work to what GenXML and GenCS did, and it code generates classes and then builds them as you say build in Visual Studio. Then also the client application if necessary. Typically it's just setting up an environment for data logicals and things like that, and possibly stripping out a little bit of code that connects and disconnects and does xfServerPlus logging and things like that. Any code that's involved in doing the start debug, end debug, the old debugging mechanisms. So typically you can clean a little bit of code out of the client application, but again, typically you don't have to if you don't want to. It doesn't do any harm to leave it there. And typically the application can be made to be up and running fairly quickly. In terms of creating and configuring the Interop project, it's just a project template in Visual Studio. There's nothing special about an Interop project. It just creates a class library. It just creates a DLL just like a regular class library does. It just has some extra tooling to generate the code as well. You set the namespace. There's a way of setting the namespace that you want to use for the generated code, and you would go off and look at your GenCS scripts and make sure you configure it for the same namespace, because that's what the client application is going to expect. There are a bunch of additional Interop settings in the project properties for the Interop project, and those are basically all the same options you had with xfNetLink.net. If you created your xfNetLink components through a Workbench xfNetLink project, then you had some very similar UI that let you pick these options. So you just select the options, set it up the same way your xfNetLink environment was set up, and you should wind up with a very similar result. And remember, you probably need to configure environment variables for things like your repository so that the compiler can find your repository and so on. Once you've done that, you simply add the Synergy method code into the project. You don't have to, but I like to create a folder inside the project. I quite often call it methods and just dump everything in there. And then basically when you do a build, the Visual Studio will create a generated code folder, and it will put the code that it generates in that folder. So I like to keep things, but you don't have to. You can put the code anywhere in the project, but I like to keep the two things separate. You'll notice also it generates a Synergy routines.dbl. It contains a couple of stubs for the old xfPL log and set xfPL timeout routines that the xfNetLink client used to provide, just in case your code calls those. They don't do anything, but it just allows the code to still carry on building. And if you don't need those things, there are options in the Interop page to say, no, don't generate all that additional stuff, I don't need it. Once you do that, you build the Interop assembly, and you can see now we get a generated code folder, and it contains source files that basically have the same names as what GenCS used to generate, except they're .dbl, not .cs. And if you look inside those, you find the same classes and structures and enums and all the stuff that GenCS used to generate, the Interop project now generates, but DBL, not C#. Altering the client application usually is very simple. You simply remove the references to your xfNetLink assembly, you remove the reference to xfNLNet, you add a reference to the new Interop project that you've just provided, and you hit build. And generally speaking, your client application you would expect to just build. It may not run, again, you may have to configure some runtime settings to let it find its data and stuff like that, but generally speaking, it's not difficult to amend the client application. Debugging with the Interop is a world different from xfServerPlus. Clearly, you've got with xfServerPlus, you had to do the remote debugger and telnet in, start the debugger, start the instance listing on a port number and telnet into it and all that kind of stuff. You just set a breakpoint wherever you want it and hit go, and off you go in this environment. You've got a full fidelity Visual Studio debugging experience all the way through to the traditional Synergy subroutines and functions, and you can just debug away till your heart's content. It's really superb. Exposing, you also have, xfNetLink.net had a little minus whatever it was, minus W switch, I think it was, on GenCS that said I want to be a WCF service, so that you could host an assembly as a service. Interop has the exact same options. There's a checkbox in the properties that says be a WCF service. So it just adds those additional service contract, operation contract, data contract attributes. and allows you to carry on creating your WCF service via Interop instead of via xfNetLink if that's what you wanted to do. It is now possible to customize and extend Interop classes. We moved a little while ago to making these things partial classes. So it is easy to code generate the stuff that comes from the xfNetLink world and then decorate it with a second or third partial class to add your own functionality into there. And there are some new options. I won't go through all these new options, but you've got the options to implement the iDisposable pattern if you've got cleanup you need to do. There's ways of using alternate repository field names. Basically all the same things that existed. Well, most of these existed as options in the GenCS, the xfNetLink world as well. Primary advantages, 100% .NET solution now. You're not a distributed application running over some custom proprietary protocol on the network. You're now 100% in-process .NET. And again, if you still need client server, then xfServer can get you over the wire back to your data in conjunction with the select class, hopefully. So full fidelity debugging from client to server, although it's not really client server anymore. In-process execution of code, simplified licensing. The xfServerPlus licenses have gone away, of course, but now you're using a runtime license instead. So, there might be some considerations there that you need to take into account. Briefly, I'm not going to go into a lot of detail because it's a fairly boring demo. And to be honest, a lot of you have seen it before, and actually this is in Code Exchange. There's a thing in Code Exchange called, I think it's called Client Server Examples or something like that, that has like 6 or 7 demos of all kinds of Synergy.NET, xfServerPlus stuff, and Interop stuff, and WCF stuff. There's all kinds of stuff in that scenario, and I just lifted these demos from there. But just to give you an example, this is a traditional or typical xfServerPlus environment. So here we've got an ELB project in Workbench just with a bunch of subroutines and functions. Some of them are doing select class stuff, some of them are opening and reading files directly. It's an optimistic locking environment, so I'm passing GRFAs around through binary handles and things like that. And it's a stateless optimistic locking environment. It gets built into an ELB. This is a .NET component project, so this is where we generate our xfNetLink .NET component. Here's all those attributes that we talked about that determine what GenXML does and what GenCS does and so on. Out of this project comes the .NET client assembly. And then on the client side, here's our Visual Studio environment. We've got references to the thing that we generated with xfNetLink.NET and a reference to xfNLNet itself and the client application, which is a very simple, this was written several years ago actually, so it's actually, Richard will throw his arms up in horror, but it's a WinForms app. And if we run it, then here we are so we've made our connection to xfServerPlus. We've called a method to say, give me all the customers. These are customers. We've made a method to say, get me the contacts for the selected one. We're editing it now. We can switch customers and pull, it's making xfServerPlus method calls all the time for this and so on. And there's the environment working. And obviously all this data, even though it's all running on my laptop here, all this data is going via TCP/IP links. Okay, so there are certainly some inefficiencies there. Okay, I'm not going to actually go through the code. If you're interested, you can download it and look at it yourselves. What we will do is just look at the Interop alternative. So now we're all in Visual Studio, so we can get rid of our workbench here, and now we've got our client application is here, and then we've got our Interop assembly is right here. Here's methods. So this is the exact same code that was in the xfServerPlus world. Literally, it's the same physical source files. I didn't even copy them. It's literally the same code. So here's our subroutines and functions in the .NET world. And you can see that when I built, it's given me generated code. And this is, again, the API that the client is calling. And then the client app is now just calling straight into these wrapper classes, which are now directly, if we look in contact service, which is the main driving class with the methods that get called, here's our get address for update method, and you can see here it's actually calling the traditional Synergy or the Synergy function. So this is the OO get address for update method that the client app calls, and it calls directly back into the function. It wraps up the data as it needs to, still turning it from .NET types into Synergy types, because this is a subroutine and function that takes Synergy data types, whereas this OO method takes .NET data types. Okay, and that's what our client's calling. So again, not going to go through too much code. Let's just run the app and just show that it does indeed continue to work. I literally did not have to change anything in this app. This app did connect and disconnect itself, so there is still some code in here that says connect and disconnect, but it's not actually doing anything anymore. And the app is now running directly in process, directly accessing the ISAM files. No more TCP/IP, and everything just works. Okay, and just very quickly, because I am slightly over time, let's just for the sake of it, let's go to, if we go to update contact, here's our update contact subroutine. Let's just put a breakpoint in here where it opens the file, and let's hit go. And if we go and run the application, and let's go pick a contact and change something and say, okay, so here we're about to call update, and sure enough, we've broken in the subroutine. Okay, that's an awful lot easier than remote debugging. Okay, I do have the obligatory recommended reading. Googling the error message and temporary workarounds are both books that I've found to be extremely useful. Highly recommend. Are there any questions? Okay, thank you very much for your attention.